And are you there, Regina?
Yeah, I think I am. Can you hear me?
She's here. I can hear you.
Okay.
All the way
Can you
back from the
see my
UK.
screen?
I see your screen. It was nice of you to fly home so quick.
Yeah.
Regina just gave the keynote at Foster G UK. So now she's going to bless us with her presence here. And yeah, tell us the story, Regina.
Okay, so I'm going to cover not so much the PostGIS extensions, but other extensions that extend PostGIS. And before I start, I guess I should mention the books that I've written. And there are 4 of them in reverse chronological order listed there. And PostGIS in Action, by chance, is 48% off if you buy directly from Manning on hard copy and 25% off on ebook. And Locate Press is running a promo, 25% on the ebook of PG routing. And I'm working on 2 new books, which hopefully I'll be done with in the not too distant future. So before I begin, I'm just going to talk about what PostGIS solves. So PostGIS solves spatial problems, and it allows you to also manage space. And the extensions that are in the box are the ones that come packaged with the PostGIS project. So they're managed by the PostGIS project. And the ones that are outside the box are ones that are packaged separately from PostGIS, but rely on PostGIS in some way or another. And I think there are many more extensions for PostGIS, but these seem like they're the most mature of the PostGIS dependency extensions. So the PostGIS project, the main extension is called PostGIS, and it includes a geometry type that models space as a flat. And then the second type, also part of the PostGIS extension, models it as a spheroid. And then there is the PostGIS raster, which manages it as a numerical matrix. And finally, there's the declarative model, PostGIS topology, which manages objects as interrelated to each other. And so the geometry type includes these basic types. It includes 2D geometries that we're used to, but it also includes the definition of polyhedral surfaces, which are 3-dimensional, and basically they're composed of patches of polygons. The triangulated irregular network is also used for 3D, and it models 3D objects as triangulated irregular networks. So basically a patch of triangles. And as mentioned, the PostGIS extension has the geography. That's what you should think of when you think about geography. The raster contains the raster type itself is a numerical matrix, but if you pick out a value, it's a numerical array where each element is called a band, and each value is a pixel value. And then the topology models geometries as connected edges. So if, for example, 2 parcels share a boundary, you only have one boundary. And so this is pretty good for cleaning up cleaning up geometry data, and also ensuring that things are where they should be, that things that share really still share, rather than having gaps and so forth. The PostGIS project also includes command line tools, and the most popular ones, the ones that have existed for the longest, are the SHP to PGSQL, which allows you to load Esri shape files, the PGSQL to SHP, which allows you to export PostGIS data as Esri shape files, and the raster to PGSQL, which allows you to export raster data in hundreds of different raster formats. And most recently is the PG Topo export and import, which allows you to import PostGIS topologies and also export PostGIS topologies. And so the PostGIS project also includes an extension called PostGIS Tiger Geocoder, which doesn't really have its own types, but it has tools for loading US Census data, which includes edges, street lines and places and so forth, and uses that data to help you geocode. And a companion extension to that is the address standardizer, which converts representations of textual addresses into the same textual representation and breaks it up into its component parts. The PostGIS SF Siegel is another extension, and it doesn't include any types either, but it leverages the PostGIS tin and polyhedral surfaces mostly, and it also introduces some 2D advanced functions and a lot of 3D functions. And so these are the ones that are new in 3.3. The optimal alpha shape, ST alpha shape, there's equivalent in 3.3 for base PostGIS, but that requires GIS 3.11. But they do very similar things. And so now I'm going to switch to demo as soon as I figure out how to change the share screen. Okay, can everyone see my screen? Okay, great. So usually the first thing when I'm setting up a PostGIS database I like to do is check what version of Postgres I'm running. With this function, select version, and that's just part of PostGIS. And it's usually the first thing I ask people to do when they come in with problems, because you want to know what operating system they're on and what version of Postgres, and this tells you all of that. And then the next thing, which I'm going to skip, is to create a database, set the search path of it so that where your data, you want your data to go is the first schema, and then the other ones are helper schemas that contain functions that you need. And if these, I like to keep my extensions in separate schema from public. So I usually create like a contrib for non-PostGIS stuff, and then I create a PostGIS schema for all my PostGIS functions and PostGIS related extensions. So the first thing I usually do is install PostGIS in the PostGIS schema. If you already have PostGIS installed, you want to run this function called PostGIS extensions upgrade. And what this does is it upgrades you to the latest version of PostGIS that you have the binaries for on the system. And so after you do that, you want to check what version of things that you're running. So that tells me I'm running PostGIS 3.2, and ignore this part because this is my development box, so it's probably screwed up a little bit. But normally you don't want to see needs upgrade here. And the GIS version will tell you what functions are enabled. So some newer functions, as I mentioned, the concave hull, the newer concave hull and polygon hull require 3.11. So if you try to use those functions, they'll I won't be able to do it with this one. And also other important ones are the Proj library, which tells you what kind of transformations you are capable of. And SF Siegel, some of the newer functions require SF Siegel 1.4.1. So they'd be disabled if you have a lower version. Okay, so now we have our PostGIS set up. And The best thing about PostGIS 3.3 is after 20 years of development, we can finally write a hello program with one line of code. And so that's hello world in the geometry form. We can convert our geometry to geography. And this is an example I like to use because it demonstrates the difference between geometry and geography. So if you look here, geometry just repeated the world twice. But geography recognizes that, hey, even though those coordinates are different, they're the same coordinate. So it wraps. And this new function, ST letters, can also take your own set of fonts, but I'm not going to explain the details of how you create your own fonts. And I evidently do not have my fonts loaded in this database, so I'm going to skip that. And then the address standardizer allows you to standardize addresses, and it had there's two parts. There's the address standardizer, which is the parser, and then there's the address standardizer data US, which is the it contains the data that and the rules for how to standardize. And you can modify it yourself or create a derivative of that if you don't like the way it standardizes things. And the PostGIS Tiger geocoder actually has its own set that it uses. It doesn't use this one. And so that'll allow you to split things out. So, and the JSON, each function that's built into Postgres allows you to split out columns into to separate rows. And the PostGIS Tiger geocoder, I'm going to skip how to load the data, but basically it allows you to geocode a location. So we notice this is here somewhere. Yeah. Yep. So that's the location, which isn't that far away from me. And the ST letters, it always positions things at null island, what's called null island, the 0, 0 coordinate. So in order to move it somewhere else, you just have to translate it. So I'm going to add two geometries, one that translates hello world to that position, another one that shows Boston. So if we look at this, we see that that is now positioned there. And I have this, which I actually took from the Tiger data that I loaded. So the first non-PostGIS extension I'm going to cover is the H3 extension. And this has grown in popularity fairly recently. And what it does is it uses the Uber H3 library and exposes it as a SQL API in PostGIS. And I'm the Windows bundle, PostGIS Windows bundle packager. So I plan to package this in the next version of PostGIS, which hopefully will be coming out in another week or less. And so it has two extensions. It's composed of H3, which has no dependency on PostGIS at all. And it also utilizes built-in geometry types in Postgres. Yes, a lot of people do not know Postgres has its own geometry type. So there's a geometry type called polygon, which is very simplistic. And H3 can display itself in that. The H3 PostGIS extension is a binding between the the H3 and the PostGIS. So it has a dependency on both H3 and PostGIS. And it allows you to convert the Uber hexagon geometries into PostGIS format. And the first thing I usually like to do, most of the extensions that come with, most of the PostGIS extensions tell you what version they have. So there's always a function that tells you the version. In this case, it's H3 get extension version. And so that tells me I'm running 4.03. And there's probably a lot of functions in here. Let me just see if I just go through the list so you could see them. This is the right. Okay, maybe yeah, you'll see the H3s after all these underscores. I guess everybody went with the underscore idea to have what they consider private functions. So you'll see all these H3 functions start with H3. So it's easy to pick them out. And one thing you could do is you could create a table and you can index based on this H3. And I'm going to show what this does. Basically, for all the geometries here, it's going to divide it into hexagon cells and insert them into this table. And you can do things such as figure out the area of these things. And the newer version of H3 supports Brin index, which I don't have time to go over, which I guess I already have. And if you wanted to look at it, so there's two things you should be aware of. The first is you use this H3 cell to boundary geometry to convert a hexagon, a H3 hexagon to a PostGIS geometry. The collect function is an aggregate function built into PostGIS that allows you to collect all of them. So if I look at this, you will see it is composed of hexagons. And the geometry, you would think that the geometry converts to hexagon, but it doesn't. It just gives you a whole bunch of points, which are the centroid of each hexagon. PostGIS also has a hexagon function, but it has nothing to do with H3. It uses the hexagon, the SC hexagon grid function in PostGIS uses whatever spatial reference system you're in. So it could be equal area if you're using a area preserving spatial reference, or it could be non-equal area if I'm using something like the geometry format. And one thing that's important to know about the hexagon grid is the I and J is always the same for the same size hexagon and the same position in space. So you could use it for indexing if you wanted to, but it's just that it's not a consistently name. It doesn't mean it doesn't have a universal meaning like the H3 does. And so this is what a PostGIS hexagon looks like. You can't really tell, but they're not really, because I'm not using a planar preserving coordinate system, they're not exactly equal. And the equivalent of doing cast would be to take the centroid of the hexagon. And so getting back to what I said about the H3, if you don't use the PostGIS, it uses the native Postgres geometry type, which looks like that. And if you look at it, it says polygon. So there is literally a type in Postgres called polygon. And PostGIS can actually convert those to itself, which I'm going to dare try. No, maybe I shouldn't dare try. Yeah, okay, let me skip that. You're just going to take my word for it that you can convert a Postgres polygon type to a PostGIS geometry type. And since I'm running short of time, I'm going to skip through these things very quickly. Okay, so one of my favorite extensions is the OGR FDW, which I use to load data, and I'm going to use it to load GPX data, which is useful for traces for like driving, basically monitoring anything that's moving. And one of the new functions in, one of the new extensions is Mobility DB, which is used strictly for analyzing things that are moving. And so I can take this GPS data that I loaded and I can, and that always happens to me when I do this. Well, I can load it, but I should probably stop here because I have 5 minutes left. So do people have questions, or do I have, well, let me just skip over to, let me see what I could show.
Regina, there's a few questions in the Q&A box if you want to start there too.
Oh, okay. Let me see, answered. Oh, so the Linux package. So Raj Taleti asked about the extensions, whether I'm going to have it for Linux or is it just Windows only. I only deal with the Windows packaging. There are lots of packagers that deal with Linux. For Linux, there's PGXN, so you could pull it from there. It's not like the H3 is not available for Linux to my understanding, but it's fairly simple to compile. So I think they can be encouraged to package it. I don't see any reason why they wouldn't. Okay, another question was, will the SF-Siegel extension installed, would it be the best, if any, to store a large tin, billions of triangles as coming from a large object into a PostGIS DB? Well, SF-Siegel doesn't actually define the tin. So you actually don't even need SF-Siegel to load a tin. The tin type is part of the PostGIS extension. So you need SF-Siegel to do certain operations with it. Like, for example, find the intersection of two tins. But in terms of loading, it's really the PostGIS that's doing the work there. And I've never tried loading like a gigabyte, so I have no idea how long that takes. The H3 index, it has multiple resolutions is my understanding. So I think it depends on the resolution you set it to, what the ultimate number of bytes are. Because there is a function that tells you what the resolution is. The resolution is embedded in the hash, which I found kind of neat. Oh, so another question is, is there a specific reason why I install extension functions into separate schemas? Well, there's some security concerns, but that's not really the reason I do it. The main reason I do it is because if you look, there's a lot of functions. So if you load all the functions, including all those extra extensions, you end up with 4,787. And normally it's hard to train people not to put their data in public. And then you put your functions in public, maybe. And then you can't find your functions because there's 4,787 functions to wade through. So that's my main reason. So the OGR FDW, which I ran through very quickly, it's mostly used for it. What it does is it creates a foreign table, which is not really loading data. So it's a link to an external. Okay, that's not the right schema. Yeah, here's my data. It's a link to never. Oh, okay. I put it in staging. I usually create a staging schema to load my linked tables. So these aren't real tables. They're links to files or like another relational database. And there are some drivers. So each one uses a different driver in OGR. And it depends on the driver if you can edit it or not. But you can't create a file. You can only write into it if it allows writing. But I usually use it for linking to spreadsheets, Excel spreadsheets that people like to send me, putting those in tables, and then just deleting the link when I'm done.
And before you go, we've only got you for another 3 minutes, but I wanted to ask you, I went and looked at the PostGIS mailing list from May of 2001, which was the release date, and then kind of scrolled through the months to find out when folks who were still in the community had first put an email on the list. And you're in November of 2001, so that's 6 months after release. And I don't know if you could tell me like how you found PostGIS and why you thought it was worthy of your time 20 years ago.
Well, I started off with Map Server. So I found Map Server first, and then on Map Server mailing list, they mentioned PostGIS. So, and I've always been more comfortable with databases than maps.
Mm-hmm.
So it felt more like a natural fit for my strengths.
And here you still are. Question from Thayer Young. My experience with foreign tables is that it is slow because you can't index them. Am I missing something?
No. Well, let's see. Are you missing something? No, you're not. And I think it depends. So if you use the Postgres FDW, for example, it can leverage the indexes that are on the other Postgres database. And the Postgres FDW itself has been improving for each version. So I think it depends on the foreign table. I don't know if there's, Paul, you might know the answer. Are there some like OGR drivers that you can actually leverage the index of?
Yeah, it's very dependent on what you're connecting to. Like, so if you're connecting to an Excel file, there's no index, nothing you can do about that. If you're connecting to a remote database, then you can push down logic to the query you send that database, and it's possible for it to do things. And so you can push down logic within the limitations of the OGR driver itself. And the limitations of the OGR driver are very simple Boolean true-false stuff, and then for spatial bounds. So it's not like a full spatial predicate, but it can do like a bounding box filter. So you can get a little bit of spatial push down, but not a lot.
Okay. So Nicholas' question, any way of directly loading data from OGC API feature endpoints? You could do that with the OGR FDW. I think there's like a WFS, but you could also do it with Paul's cool HTTP extension. I like that more because I just have full control. I don't even care if it's OGC API compliant.
Right. Let's get a bunch of JSON and then muck with it. Okay. This is it. We're out of time. Thank you, Regina, for spending the time to walk through that stuff with us.